Okay, so today we're going to talk about the normal curve. There's a lot to know about the normal curve, but we're just going to go over some basics. The normal curve is a graph of the distribution of the normal distribution. So, the normal distribution is a frequency distribution that often occurs when there are a large number of values in a data set. So, after that, we have what's called the normal curve. It's the graph of this distribution. It's a symmetric bell-shaped curve, and it's symmetric about the mean. So let's take a look at what this normal curve looks like. So we've got some Greek letters up top. Mu, it looks like a fancy U, pronounced mu. That's what represents the mean. Then we have what looks like a 0 with a little hat on it, and that's for the standard deviation, and that is sigma. These are Greek letters that are used in statistics. So, the mu is the mean, which is in the middle. So here's our mu, that's our mean, and it's symmetric around our mean. So, I'm going to give you what's the most important part about this. Between here and here, so between this value and this value, is 68.3% of the data. So 68.3% of our data lies between these two intervals. So what you do to get these intervals is you take your mean, which is given to you, and your standard deviation was given to you. And for this value, you take the mean and you subtract the standard deviation. And for this value, you take the mean and you add the standard deviation. So the next interval we want to talk about is if you subtract 2 times the standard deviation and if you add 2 times the standard deviation. And between these two intervals, we have 95.5% of our data. And then the next one, we have 99.7% of our data. We're going to use these percentages over and over. You have to memorize these. I apologize. So let's talk about our first example. Here's our first example. It says the mean of a normally distributed set of data is 550 and the standard deviation is 35. So if it's got a normal distribution, it'll tell you that it's a normal distribution. So it says, name the interval that would include 99.7% of the data. So let's take a look back at our normal curve. 99.7% of the data, that's this percentage right here. So we're going to be looking for what mu minus 3 times sigma is and mu plus 3 times sigma is. And that's going to be our interval. So we want to do between mu minus 3 sigma and mu plus 3 sigma. Now your mu and your sigmas are already given to you. This right here, 550 is our mu because that's our mean, and 35 is our sigma because that's our standard deviation. So all we have to do is plug into these formulas. So we have 550 minus 3 times 35, and then 550 plus 3 times 35. You put those in your calculator. The interval would be from 445 to 655, and that's our interval. Now the next thing says, what percentage of the data would be between 515 and 585? So this is the reverse of the first one. So this time we're looking for the percent, but we're given the range. So let's go ahead and we know what this interval is. So obviously it's not going to be 99.7% of the data. So we want to do something smaller. So let's take a look at the first interval. So we have mu plus sigma and mu minus sigma. Well, let's do the opposite way. Minus and then plus. Okay, so we have 550 minus 35 and 550 plus 35. When you calculate those, you get 515 and 585. And those are the two numbers that we were looking for. So that first percentage is 68.3. Now, if this wasn't the correct one, you would just do the next one and keep going from there. Now we have a C to this problem, but it's on the next page. C says if there were 200 values in our data set, how many of our pieces of data would be between 480 and 620? So, well, first of all, from before, this is what we know from the problem so far. We know that for the first two pieces, we have 515 and we have 585. And this is our mu. This is our mean in the middle. So this is the middle. We don't necessarily have to draw the curve. Then we don't know the next one. That's the mu minus 2 times sigma and mu plus 2 times sigma. But we know the last one. And the last one was 445 and 655. So this is what we know so far from our previous examples on this. So we want to know from 480 to 620. Well, first of all, we got to figure out where 480 and 620 are coming from. Highly likely that we're talking about these two pieces of data right here. But we want to double check. So we're going to have 550 minus 2 times 35 for this one. And you get 515, which is what you're looking for. Not 515, excuse me, 480. Jumping ahead of myself. And then for this one, you have 550 plus 2 times 35. And for that one, you get 620. So we're talking about these right here. And we want to know the percent there so you can figure out how many actual pieces of data are here. So if you go back to your normal curve between the mu minus 2 times sigma and the mu plus 2 times sigma, that's 95.5% of our data. So the last thing we want to do is we want to know exactly how many pieces of data would lie between these two values. So we're given that there's 200 total values. So we want to find 95.5% of the 200. So we have to write 95.5 as a decimal and multiply it by 200. Put it in your calculator and you get 191 pieces of data. And that's our final answer. So that one's a little bit involved. You had to figure out where these two numbers were coming from. You had to figure out what percent they're talking about. And then you have to calculate that percent of the total pieces of data. So we have another example. So here's example 2. It says that suppose 600 values are in a normally distributed data set. So we're not given our mean and we're not given our standard deviation. So hopefully none of these questions will ask us anything where we need that. A says how many values are within one standard deviation of the mean. So let's go back to our normal curve within one standard deviation of the mean. We're talking about this right here. We want to know what 68.3% of the values are. So we're going to take 0.683 and we're going to multiply it by 600. And you get 409.8. Now, we don't like to have parts of pieces of data, so we're going to make this 409. So 409 pieces of data lie within one standard deviation of our mean. So then B says how many values fall between the interval that is one standard deviation below the mean and the mean. So I'm going to go back to the normal curve. So this time we're looking for the values of this interval. So we've got this lower interval. Now remember, the definition says that it's symmetric. So all we have to do is take 68.3, which is this interval right here, And we're going to divide it by 2 since it's symmetric. So if you take 68.3% and you divide it by 2, 34.15% of our pieces of data would be in this interval. So let's go back. So 34.15%. So we're going to take 0.3415 and multiply it by 600 because that's the pieces of data that we have. And we get 204.9, which remember we can't have parts of pieces of data. So we have 204 pieces of data that lie in that interval.